So we're talking about solving for W. Jason said to solve for W, we need to get W by itself. I agree. That is true. Jason or Chasen? Chasen. Jason said to solve for W, you need to get W by itself. That is true, but that is not all we need to do, right? Because I could just randomly say W equals and push everything to the right, right? So there's a criteria for that. There's a certain strategy besides knowing we have to solve for W, and we do. So, go ahead.
I was thinking we're probably -1.
So I just add 5?
Yeah, so -4 plus 5.
You're on the right track, but not exactly right. So I think you're trying to do the steps for me, but I want to explain, how do I know I have the right answer? Let's put it that way. How do I know I've solved for W?
Well, whatever you get, you plug in.
There you go. So if I plug 2 into W, 3 times 2 is 6 plus 5, that's 11. Equal means the left side has to have the same value as the right side, right? Whatever that equal sign is separating, those two sides have to be equal. They have to have, if one is -4, the other has to be -4, right? So once we find the value for W that will make the left side equal to the right side, then we have solved for W. Okay? We are, to Jason's point, our goal is to isolate the variable, to get the W by itself. So we have a strategy for that. We have steps for that. Some of these you can guess and check, right? But that's not what we're practicing today, right? We're not practicing guess and check. I could guess and check. These are not hard ones. We could just pick a number, plug in. Oh, that's too big, that's too little, based on that, right? But there are steps that we can use to solve this equation that we can use when we get a lot more complicated equations, right? We're going to have a lot more steps. This is a 2-step equation, right? We're going to undo 2 operations here, right? Sometimes we're going to have 6, 7 steps. I definitely can't do that in my head. I could guess and check. It would be a lot harder, take me a lot longer, right? All right, so the thing that we're going to look at doing is, we know if we knew what W was, we could plug it in and use the order of operations to simplify that, right? What we do when we're solving or getting W by itself is we're going to do the opposite of what we would do if we're simplifying. So we're going to do the last thing. The last thing in the order of operations is executing the addition and subtraction, right? In this, we're working backwards. We're going to do that first. But before we start deciding what's what, we need to decide what is actually happening to the variable, right? 3W. What does 3W mean? Very good. 3 times W. So we're looking, our goal first is to see what is happening to the W. We identify what's happening, and then we know how to undo it, right? We know how to do the inverse of that operation. So, Jaden, right? Jaden says this is 3 times W. It is. This is the only operation that you don't see a symbol for, right? Even division is a fraction bar, right? Or the little funny, I forget the word for division symbol, but anywho. So we know that this W is being multiplied by 3. What else is happening to this W? We're adding 5, right? So we need to undo multiplying by 3, and we need to undo adding 5. How do we undo multiplying by 3? We divide by whatever we multiply. In this case, it's 3, right? How do we undo adding 5? Very good. Now, which one of these are we going to do first? That's right. Subtract is the last operation we do for simplifying. It's the first we do. There are some exceptions. Our next problem we're going to get to see some of the exceptions, but we undo that addition or subtraction first, so that's what we're going to do. Now the thing about an equation is it has an equal sign. It says that the left side equals the right side. So imagine when you were a little kid back in the good old days and you had a recess and you had a playground that had all the things you could climb all over. And you had a seesaw, right? You guys call it a seesaw or a teeter-totter? Seesaw. I lived in the north when I was a kid, and I think we called it a teeter-totter. Anywho, if you were in kindergarten, did you want to be on the seesaw with a fifth grader? What happened? They're either going to pop you off, or they're just going to hold you down and you can't get off, right? I was a little bitty squirt, so even kids in my age, sometimes if I got on the seesaw with them, they would just sit on it. I couldn't get off because it was too high. I was scared to jump off, right? So we need to think of this equation as something that we need to keep balanced. The most fun way to use a seesaw is to have two people that are pretty much the same weight. You can hop up and down, take your turns, right? We have to keep this balance. If I take 5 away from this side slider pops up, right? I'm out of balance, right? If I add 5 to this side, I'm still out of balance. Now, if I subtract 5 from both sides, nothing changes. But add 5 to both sides, nothing changes, right? So our goal is not to change the value of our equation when we're solving for our variable. Okay, so that being said, we are going to undo the adding 5 first, and we're going to do that by subtracting 5 from both sides of our equation. Now we're going to do the math. 5 minus 5 is 0. So on the left side, I have 3w plus 0, which is just 3w. On the right side, I have negative 4 minus 5. I really, really, really want you to use your calculator for that. Some of you are great at adding and subtracting positive numbers. Even people that are good at it on a test is really kind of what I'm talking about. Double check your integers on a test. Jason?
I did plus 4 to negative 4 to so then divide by 3.
No, but thank you, because you've given me a great example, and I can show you why it doesn't work that way, all right? So Jason said, don't write this down. He said he added 4 to both sides, correct? Yeah, and that's great, right? You kept it balanced anyway. So we could do that, but what you have left now is 3w plus 9 equals 0. Did you put equals 0 there?
I just said 3w plus 9.
Yeah, and you've lost your other side, right? So if you do it this way, you can do that, but really you just create an extra step, because I still now have to move that 9 away from my w, right? I've got to undo adding 9 now instead of undoing adding 5. Super, super common mistake, especially at the beginning before we reviewed, okay? So that's why I say we're focusing on the variable. This negative 4 is never going to tell me what to do. I ignore that negative 4 completely when I'm deciding what to undo. All right? So now we have 3w equals negative 9. Divide both sides by 3. What's any number divided by itself? Just 1, right? 3 divided by 3 is 1. So that's our goal, to get a 1w here. Negative 9 divided by positive 3 is negative 3. All right? So we think that we have solved for w. We've definitely tried to undo the operation. We definitely have w by itself. This is the only one we're going to check, but we are going to check this one. I want you guys to use your calculator. All right, so we're going to check to see, did we get the correct answer? The way we're going to do that is we're going to plug it in to the original equation and see, is this expression on the left, does it equal negative 4? Right? So we need 3 times negative 3 plus 5. We need to see what that equals on our calculator. So let's practice using our calculator. Times 3, the opposite button, plus 5. Did you get negative 4? So this is negative 9 plus 5. You should have gotten negative 4. Anybody not get negative 4? Okay. I'm going to erase this over here, and we're going to do example 2. Okay. Does example 2 look like example 1 to y'all? Yes, pretty much, right? I will tell you, because this variable term is not the first term here, sometimes kids get confused on how to solve it, right? Some of you are not going to have any problem with it, right? So really I'm talking to the kids that may not have as much confidence about solving these two-step equations. I do not want to know who you are right now. I do not want you to think you have to tell me who you are. But I know that kids have a tendency to mess up each sign if you leave this values here. Let me ask you a question. Does 2 plus 3 equal 5? Okay. Does 3 plus 2 equal 5? So does it matter which order I add these numbers in? It does not, right? So if I switch these two numbers, as long as I keep the sign the same, so this is a -2 or a -2, and this is a positive 5u, so I can rewrite this as 5u minus 2 equals 33. Now, I would like everyone to do this on your notes today, but if you are a kid that matters not to you, it does not confuse you at all, you don't have to swap those to solve it. Right? But now, we've got our variable term first. It's clear that this is a -2, right? So now we're going to pick our operation. What's happening to the 5 here? What's happening to the 5? I need to learn names. Let me look at a seating chart here. Leilani. What's happening to the 5? I mean to the u? Is it being multiplied? Are we multiplying it by anything? So 5u means times 5. And then minus 2. Those are the two things that are happening to the variable. So whatever is happening to the variable, we need to undo. Okay? So what do I need to do first? What do I need to do first, Patrick? What do I need to do first? Okay, don't put your head back down, all right? I feel like maybe I'm not getting all your full attention. This is 5. We've said that the u is being multiplied by 5, and then we're subtracting 2. So which of these operations am I going to undo first? The multiplication or the subtraction? Yes. Let's make a note of that. We're going to undo addition and subtraction first. There are exceptions. We're about to see an exception, but mostly that's what we're going to do. So we're going to undo that subtracting. Patrick, don't put your head back down, babe. Sit up. Okay, how do I undo subtracting 2? Jeremiah? How do I undo subtracting 2? So if I subtract 2 from both sides, am I going to undo that? All right, so we do the inverse, right? If this is subtracting, the inverse is adding. If this is multiplying, what's the inverse? Kaden? What's the inverse of multiplying by 5? Dividing, that's right. So we're going to add 2 first to both sides. -2 plus 2 simplifies to 0. 5u minus 0 is 5u. 33 plus 2 is 35. Caitlin, what do I do next? Perfect. So now I know that simplifies to 1u. Now I know that u equals 7. your homework should look like this. I should see a step-by-step process, and then at the end you should box your answer. Okay? Any questions on examples 1 and 2? Now I told you just the last slide that we undo subtraction and addition first. However, if there are grouping symbols, we are going to simplify those first. There are a couple ways to do it, but I'm going to ask you to do it this way. If you know another way to do it, great. Right now, I'm going to ask you to use a distributive property. Does anybody remember what the distributive property is? Kind of. So, how would I use the distributive property here?
With the
Perfect. This says 9 times y minus 2. The first thing I'm going to do is I'm going to multiply that 9 by both things inside the parentheses. I will tell you already today, I've seen a couple kids, really smart kids, get every other problem correct. They just forgot to multiply the 9 by the 2. Right? They multiply it by the y, and then they put minus 2, right? So don't forget, everything is multiplied by that outside number. So this is going to simplify to 9y minus 18 equals 18. And now we look at, okay, what's happening to the variable? What's happening to the variable here? Can you tell me what's happening to the variable, Brandon? Multiplied by 9. Anything else? Perfect. So we're going to undo that using division. We're going to undo that by adding, right? So let's do it. Add 18 to both sides and do the math. This should equal 0. If it does not equal 0, something is amiss. Negative 18 plus 18 does simplify to 0. So what we have left on the left side is 9 times y. 18 plus 18 is 36. Now we said we're going to divide. So dividing by 9. 9 over 9 simplifies to 1. So y equals 4. Any questions? Can you go ahead and distribute here and rewrite that step for me? I'm going to let y'all do that ahead of me, and then I'm going to do it. Let you check it. All I want you to do right now is distribute. Yeah, so actually not to do that yet. But if you don't want to wait to do that, okay? You multiply by 5 to get that. You didn't use right? But now that I know straight to that, come out your rate that. So when we get to that, we're working on that one pretty soon. Okay? So you can go ahead and erase that one. But this is perfect. Okay? So I'm going to erase that one. And start working on that one next time. All right, what did you get when you distributed? What did you get when you distributed? Tremont? Say that again? We're on 4. Did you distribute the 2 to everything in your parentheses? Can you do it with me now? All right, let's do it together. Perfect. Yes. 2 times 3w, 6w, plus 14. If that is not what you got for that first step, let me know, or if you have a question. If you understand now, great. Now we're where we look at, okay, what are we doing here? We're multiplying that variable by 6, adding 14. And so now we're going to undo those things. Undo our addition first by subtracting 14 from both sides. So now we have only 6w on the left. 68 minus 14 is 54. Now we're undoing this multiplication by dividing. You see, I'm not writing out every single step anymore. If you know that you need to build some mastery of these things, do all these steps for a little while. Eventually you won't have to do them, but you'll have a better chance of getting things right the more you write down. All right? And so if we plug in 9 here, 3 times 9 is 18. 18 plus 7 is 25. That's it, right? Oh, it's 3 times 9, 27 plus 7 is 34. That is right. 34 times 2 is 68. Had a senior moment. So left side does equal the right side. If you're cracking jokes, make sure everybody can hear them or don't say, oh, all right? So if it has to be a sneaky one, you probably shouldn't say it, right? Be brave or don't do it. Do not bold. No sense in doing it. Good. It doesn't need repeating them. All right. What is happening to W here? Nice. So that fraction bar means to divide, right? We think of it as a fraction, but a fraction is a division problem. So it's being divided by 5. So how are we going to undo dividing by 5? That's all. We're adding 2. How are we going to undo adding 2? Subtracting 2. All right, so we're going to start with that subtracting 2. Humor me, use your calculator here. 2 negatives. Sometimes it's a problem for kids, but that is negative 5. If you're not super confident with the positives and negatives, always use your calculator to double check. Good to start on your own without it, and then double check it with your calculator. All right, now we're undoing a multiplication or a division by multiplying. We're going to multiply both sides by 5. This is a fraction, so I'm going to make this one a fraction. There's a couple ways to write this one. Right? Top times top, bottom times bottom. But 5 divided by 5 simplifies to 1. Now we know W equals negative 25. This is the first one with a yes. Say it again. That is another strategy. You could multiply. I will say that somebody did that already, but they forgot to multiply the side, the number on the opposite side of the equal sign. It only works if you multiply everything by that. So I'm kind of showing you a strategy that you can use for almost everything. Right? Are there other mathematically sound ways to solve these equations? Certainly there are, right? But I find that kids, if we can try to do things at almost the same steps every time, kids have a much better success rate. It's easier to remember if you're not trying to remember a bunch of different ways. But when you understand it completely, it sounds like you have a really good understanding. That is an option. Okay? So 16, or example 6 rather. Negative 16 equals y divided by 2 minus 6. What are we going to do first? Plus 6 it is. To both sides. This goes to 0. You find everything? Good. Now, negative 16 plus 6. Use your calculator. We're going to undo dividing by 2 by what? Multiplying by 2. That's right. I'm going to multiply this one by 2 and this one by 2. So I have 2 times negative 10, which is negative 20. And I have, I can put that over 1. And I can multiply it like I did here. But do you remember back in the days we got to cross cancel top and bottom? could also just cancel those simplified methods that way, so all we have is 1 times y over 1, which is just y. Okay? We are going to flip this around. Negative 20 equals y, and y equals negative 20. They asked us to solve for y, not to solve for negative 20, so I would like for you to put your answer, what we say, in terms of y, so put your variable first, okay? Any questions? Okay. You guys have time to start your homework? So that's what you should be doing now. And by design, this is not classified as homework in the grade book. This is an assignment. Right now, this is a classroom assignment. If you don't finish it, but you're working hard today, I'm going to let you finish it for homework, right? I've had in the past, if I call it homework, kids go, well, I'll just do it at home. But the design is to have you start in class, that way you can some help. I'm here to help you. I do have a key up here on my standing desk. If you finish it and you want to come check it, you can. Oh, over there on that top end. It's going to be, you can't just add 7 over here. You have to add 7 to both sides. It should look more like a negative number. Make sure you show the work for a correction if you're correct, all right? Not, if you don't understand it, I can help you with that. Normally, when you calculate straight, I should check with it. For whatever reason, it's having a great point. Yeah, that's right. So, this is a positive. Tell me how you thought that. Thank you. Did you subtract 3 from this one? If you subtract 3 from this one, you get a positive. Yeah. So obviously you've been taught to do it a little bit differently. Yeah. And that's okay, but you do have to be careful, right? That's the good area step too, right? So I need to see this step as well. How could you show that step? Is this a problem? How could you show me that one? You did it up here. So yeah, I know you did it in the middle. Just show them. You think it that way. Okay. I just need to see something so I see that step. Okay. Right. Perfect. No problem. I want to count that. Same thing, I just need to how you got this, right? So anytime you do that, I need to see some words somewhere like that, okay? Not how I would do it normally. This works pretty well, pretty straightforward. But when we start getting into some more elaborate equations, and that's going to get a little bit more confusing. Okay? So if you do it, instead of pulling it out to the side, just do it within the problem, within the equation. I'm not going to say you have to, because I can finish you in the process, okay? And later on down the road, it might get a little bit harder to do it yourself. Okay, so let me do the question. Good job. How'd you do? Nothing wrong. So we are almost ready to be out of here. You can tuck it away. Tomorrow we'll stand in this class together. Okay. Remember, no phones or anything out until you leave the room today. So you're going to keep it until tomorrow? Do you have a folder you put in? Let me give you, nope. Let me give you a folder. Let me help a little bit. You want one you have to put some little holes in it, or you just want one with a pocket? Preference? No, please. Anybody else need a folder? All my notes should be kept in its own folder. You have that in your phone yet? I'll finish this, but it's okay. I'll let it generate tomorrow. Okay? Tomorrow when we come to class, and I give you the answers, everybody take it, answer questions, and then we're all going to stand and submit them together. Okay? Okay.